presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on industrial applications of electrolysis. This will be our second lesson on this topic. Last time, we learned about how electrolysis is used during the electro-refining of metals, as well as during the electroplating of metals. We learned that electro-refining is a method of purifying an impure metal using electrolysis. The main purpose of this is to get rid of the impurities in a metal. We learned that electroplating is the electrolytic deposition of layering of a less active metal onto the surface of a more active metal. The main purpose of this is to prevent the corrosion of active metals. However, electroplating is also used to prevent metal items from being scratched or dented and to give them a richer, more pleasant appearance. In today's lesson, we are going to learn how electrolysis can be used to produce metals such as aluminium. This is done using the Hall process. But also, we will discuss how electrolysis can be used to produce nonmetals and some compounds. Let us get started. The compounds of very active metals are not easy to decompose. Thus, in order to obtain these metals, electrolytic reduction is necessary. Electrolysis can also be used when pure samples of certain metals are needed. Molten metal chlorides are usually used as electrolytes in this process. This is because they generally have lower melting points than other available salts. Aluminium is a metal that is produced by electrolysis using the Hall process. This process involves dissolving alumina in molten cryolite, which is a molten metal fluoride. This is done at the cathode. The cryolite lowers the melting point of alumina by half, from 2000 degrees Celsius to 1000 degrees Celsius at the cathode. This process is performed in a vessel made of iron and lined with carbon, which serves as the cathode. The anode is created by taking carbon rods and inserting them into the melted mixture. When the mixture electrolyzes, pure aluminium is produced. Students, let us do an activity. In a moment, you will see a list of possible choices to help you answer the following question. During the Hall process, what material is used as the electrolyte?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. During the Hall process, a mixture of molten aluminium oxide and cryolite is used as the electrolyte. Other examples of metals that are produced by electrolysis include sodium, lithium, and magnesium. Let us continue with today's lesson. Non-metals can also be produced using electrolysis. Fluorine, which is the most electronegative element, is produced this way. The electrolysis of a molten mixture of potassium fluoride and hydrogen fluoride is used. Chlorine is produced by the electrolysis of molten sodium chloride or concentrated sodium chloride, which is a brine solution. Let us use the example of the electrolysis of water to explain the process. The electrolysis of water produces hydrogen and oxygen. Since pure water is not a very good conductor of electricity, a small amount of ionic solute is added to increase its conductivity. The ions that are added must be more resistant to oxidation and reduction than water. In this video, you can see the hydrogen and oxygen gas that has been produced at the top of each tube. Professor Spectacle gathers each in a test tube to show you which is hydrogen and which is oxygen by their reactivity to heat. Students, let us do an activity. Please answer the following question. Why is a small amount of ionizable solute added in the electrolysis of water?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. If you said that a small amount of ionizable solute is added in the electrolysis of water because pure water is a poor conductor on its own, and the solute improves its conductivity, then you are correct. As we discussed at the beginning, electrolysis can also be used to prepare compounds. An example of this type of compound is sodium hydroxide. Students, let us do one more activity. Using chemical equations, write the reduction at the cathode, the oxidation at the anode, and the overall reaction that takes place during the preparation of sodium hydroxide from the electrolysis of brine solution.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Here is the reduction, oxidation, and overall reaction that take place during the preparation of sodium hydroxide from the electrolysis of brine solution. In today's lesson, we learned how metals can be produced using electrolysis. We discussed how aluminium is manufactured using the Hall process. We also learned how non-metals and some compounds can be produced using electrolysis. We looked at the separation of hydrogen and oxygen gas from pure water and a solute, and figured out the reactions during the preparation of sodium hydroxide from the electrolysis of brine solution. This brings us to the end of today's lesson. Until next time, thank you, teacher. Thank you, students.